Hi everyone. Today we discuss relations between three operators, delta, del, and e. So delta is the forward difference operator. So delta of this yn is defined as yn plus 1 minus yn. That is the forward difference. And del of yn, and this is going to be yn minus yn minus. And e is the shift operator. E of yn is equal to yn plus 1. So these are the definitions of these three operators. Now we define relations between three operators. First relation is E is going to be, or E is equivalent to 1 plus delta, and this 1 is the identity operator, that is 1 of yn is equal to yn itself. Okay, or 1 of f of x equal to f of x itself. So this is the operator, identity operator, and it is denoted by the symbol 1. Now E plus, in the textbook we use this 1 and we can identify it as I. So E is equal to 1 plus delta means in order to prove this we need to prove that E of yn is equal to 1 plus delta of y. This is what we have to prove. So we start with delta yn. What is delta yn? By definition, delta yn is equal to yn plus 1 minus yn. That is equal to yn. This yn plus 1 can be replaced by E of yn minus this yn can be written as 1 of yn, and this is nothing but E minus 1 of yn. Okay, so delta can be written as E minus 1. Okay, so delta yn is equal to this. From this you can write delta is equal to E minus 1. So from this you can write this 1 plus delta is same as E. So from this you can write two relations. E is equal to 1 plus delta, or this delta is equal to E minus 1, both are the same. So from this you can write the equivalence of these two operators. Okay, now we have three operators here, delta, del, and E. So we have these are the relation between delta and E. Now we define secondly we define del. What is the relation between del and E? Okay, so del can be written as 1 minus E minus 1. Okay, we know that what is 1 minus E minus 1 of yn? That is equal to 1 yn minus E minus 1 yn. So that is equal to yn minus yn minus. E minus 1 of yn is yn minus. So that is equal to del of yn, and del of yn is defined as yn minus 1. So from this you can write 1 minus E minus 1 is equivalent to this del, backward difference operator. So this is the relation between E and forward difference, and the second one is the relation between E and backward difference. Finally we define the relation between these three quantities. Del can be expressed as delta E minus 1. Okay, now we have to prove this. For this we we start with delta E minus 1 of yn. That is delta of E minus of yn, that is yn minus 1. That is equal to delta of yn minus 1. Delta of yn minus 1 is yn minus yn minus 1. So this is nothing but delta of del of yn. So from this you can write this del is equal to delta E minus 1. So these are the properties of relation between these three operators, E, del, and delta. Now we can prove similarly we can prove so many relations connecting these three operators. In our textbook there is a illustrative examples showing so many properties or relations between them. The first one is I will prove the first one, and the rest of them has to be You need to verify all the worked out examples in the illustrated example sections, in which you can see so many relations between these three operators. So we can discuss the first example. This is question prove that del E is equal to E del. We have already seen that this delta and E, forward difference and shift operators commute each other. In similar fashion, you can easily prove this del and shift operator. Backward difference and shift operator can also be written in this form, or these operators commute each other. And this is nothing but delta, and this is E minus. We have already proved this part, and here we will prove the commutativity. Del E of Yn. By definition, this is del of Yn plus 1. That is equal to Yn plus 1 minus Yn. Okay. Similarly, you can evaluate E del of Yn. That is E of del of Yn is equal to Yn minus 1. That is equal to E of Yn minus E of Yn minus 1. E of Yn is Yn plus 1 and E of Yn minus 1 is Yn. So from these two equations, you can say that E del is same as del E. Okay. So these two operators come each other, and this Yn plus 1 minus Yn can also be written as delta of Yn. So we can say that this difference delta of Yn, by definition delta of Yn is Yn plus 1 minus Yn. So we equate this E delta and E del and del E as delta itself. And we have already seen that in the previous relations, delta is nothing but E minus 1. So this proves the example. So in the similar fashion, you can prove a number of relations between delta E and 1 and shift operator, delta, del and shift operator. Thank you.